Share the screen. And so welcome, beautiful people. Let's do it. Let me check it's working. I'm checking the chat. Okay, good. I wanted to start. Oh, I have a list. So I prepared. As always, my reviews are really good. Usually I'm very prepared, so that's good. So I'm opening your homework, which is your exam review, which is due tomorrow, right? It has lots of questions, 38 questions. And I'm going through these and give you solutions. Isn't it cool? So here you go. Let's start with chain rule. Some of you indicated that you're afraid of chain rule, but you cannot. I know you don't like when I'm saying that, but it's nice to be honest. You know, it's a personality trait. You cannot survive to 11 if you don't know chain rule. So we're kind of not supposed to pass anyone who is bad in chain rule because it's a waste of money and time. They don't pass to 11. So kind of, you have to learn chain rule really well. So chain rule will be the first topic of the exam. Let's review that first. Chain rule. There will be no product rule or quotient rule until you hit implicit differentiation on the exam. But for chain, I just left there chain rule with exponential and logarithmic functions. That's it. No product rule, no quotient rule. So very straightforward about that. For example, so let's review really fast. E to the x prime gives you e to the x, but e to the function u is u copy times u prime. That is the idea. Nicely written, it should be du over dx. This reminds you related rates problem in implicit differentiation. Shortcut is u prime. Ln of x, you just divide by everything inside of the log. You will see absolute value, doesn't matter, just divide by that thing, prime. But if it has a function inside with absolute value or without absolute value, don't be bothered by this. I know students are scared about absolute value sometimes. Doesn't matter in this situation. Just divide by everything you see times u prime, like so. So some with a multiple choice question, I put it there. You will see something like this. Derivative over whatever is inside, and you should choose that because that's the correct answer. And I decided not to be mean because I usually don't like when they put it in the tests. And I don't put e to the, I do not put a to the x or log base a on the test. I don't know, like making such a tiny mistake. Is it fair to take lots of points for that? No. So I did not put this. Only the classic ones will be there. So which is two formulas and then chain rule. Chain rule is not a new formula, right? Chain rule. It's just a chain rule involved with differentiation of exponential logarithmic function. So number two, let's just do like, oh, that's fine. Let me just give it away if I'm not against it. Exam 2 review in web work, web assign. Let's put it VWA. We have web work and web assign, different classes. So number 2. Some people are showing up. Let's see what was number 2. This one. Differentiate g of x, which is x squared minus 5x minus 1 to the minus 6. Can you do it without me? If you have exam right now, can you do it? And that's how you know, are you good at this or not? G prime is minus 6 goes down because it's power rule. Copy the thing inside because just like in the rational, you have no rights to touch it until you finish the power rule. Minus 6 and minus 1 is minus 7, and you want to stop, but chain rule tells me not to stop. Chain rule says, look inside. What do you see inside? I see a quadratic function inside. Multiply by the derivative of that function inside. And choose this from the multiple choice part, can you? If it's rewritten like as a fraction, then it might be like looking like so, minus 6, 2x minus 5 is at the top, x squared minus 5x minus 1 to the 7, positive 7, because it was lowered to the denominator. At the denominator. Can you do that? So that's definitely something to practice. Now, number 8. What is number 8? Let's not jump like so. Let's do number 6. Number 6, logarithmic function. Number 6. And this is the fun part starts. 7 times natural log of absolute value x squared plus 4. Don't care about absolute value for these cases. Absolute value just guarantees that this function exists, that inputs are not negative, because logarithm cannot exist for negatives. Prime. So what is happening here? I told you, when you differentiate logarithm, divide by everything what's inside of the logarithm. So you divide by x squared plus 4, and you can drop the absolute value, because x squared plus 4 is positive. So we don't need it anymore. Times the derivative of the function inside. I see x squared plus 4 inside. So times 2x. Don't forget, I lost something. So I'm going back and I check. Originally, the original function was multiplied by 7. So I need just to put 7 somewhere. You don't have to actually put it on the top. You can put it here. 7 survived differentiation because it was multiplied by a function. It's like a sticker. It's a rate. It will survive. So now you can rewrite it like so. 7 times 2 is 14x, goes to the top. X squared plus 4 goes to the bottom. Can you do that? Can you choose it from the list of choices? When dropping chain rule, will you accept the answer written on parentheses, or do you want it written in the final fraction? It will be a multiple choice. I did not put a chain rule as a free response at all. So you just have to choose it from the list. And I checked, most of the things we were given are looking like this. So you kind of need to see how this fraction was created. One more. Let's do something like, let me do one more just to explain how to do it a little bit faster if you want. ln of x cubed minus 5x plus 10. How about this one? Check how I see it. You divide by everything you see inside of the logarithmic function x cubed minus 5x plus 10 goes inside, times 13 was a constant, so I multiply by 13, times the derivative of the function inside, which is x squared, 3x squared minus 5. See, this one is faster to write, and you will immediately see it from this list. Like so. But both ways is correct. You don't have to create like a nice fraction like this. Exponential function, number 8, I think. Number 8, exponential function. But I would want to do 5 to the something. I will do e to the something. E x squared minus x prime. Copy. You remember the anecdote about exponential function if you attended my lectures. Exponential function copies itself. And then chain rule says times the derivative of the function inside. And by inside this time, it's in the exponent. So times 2x minus 1. And this is the answer. Don't overthink this. That's it. That's it. We don't need anything else. What do you think about that? And the combination of these. Like so. Let's do one more. With exponential function. One more. For example, 3. E to the x cubed plus 5x minus 3 plus x squared minus 3x to the minus 7. How about that? Differentiate. Let's see. Exponential function multiplied by 3. 3 times e should be copied because exponential function prime is just exponential function. but then times, look at the exponent and differentiate the exponent. 3x squared plus 5, like so. This is the result of the first part that has exponent. This is not times, this is like my star. I like it. It's a bullet point. Now, plus, and now we do what we did in the first example. Minus 7 goes down. X squared minus 3x to the minus 8, decrease by 1, times derivative of the function inside. Can you do this and find it in the list for multiple choice question? This is the correct answer. Let me check the chat. How about that? Not too bad. Don't repeat this mistake, a very popular mistake we see in the tests. Do not. E to the 3x prime is not e to the 3x minus 1. Somehow many students freak out and they write it this way. Remember, this is not how you do it. Copy, multiply by the derivative of the exponent. In this case, it's just 3. So just, I know this mistake, I've seen it everywhere. That's all you need to know with chain rule, nothing more than that. So if you was good with this, you're already done with like 2 or 3 questions on the exam, which is very satisfying. Move on to implicit differentiation. Number 15. Yes. Implicit differentiation comes right after the chain rule. Implicit differentiation. Number 15, but I'm modifying a little bit to cover several topics at the same time. For example, x times y to the 5 minus y equals x plus 15, like so. Question number 1, find dy over dx, it means y prime. Question number 2, find dy dx at the given point, which is, let's make up something, 2, 1, yeah, that's a good one. It probably doesn't make sense, I did not check it, but it's fine, doesn't matter. Well, actually I should calculate, if it's 2, I need to solve for 1, and 2 less. So, implicit differentiation, review the one that has product rule. Product rule, we give you with product rule. Because without product rule, they think it's too easy. How many questions on exam? Same way as last time. All exams are standardized. So that means 6 probably multiple choice, just like last time. And 1, 2, 3, 4. 4 questions, 5 questions, 6 questions for response. 12 plus 6, yeah, 6 questions for response. It's a bit too long. Other instructors who gave this exam, they said it felt a bit too long, so I tried to cut it down a little bit, and maybe they will curve, which also will be nice. So again, we cannot curve unless coordinator curves. She decides, since it should be fair to all the sections. So product rule, check examples in the review in another PDF file review with product rules. So let's do it. Implicit differentiations means you kind of drop the bomb and differentiate everything you see in front of you. X times y to the 5 are 2 variables multiplied by each other. The difference is x is independent variable, which means x prime is 1, while y depend on x, and that's why it's called dependent variable, which means y prime is y prime, or dy over dx, dy over dx, and that is the difference. One has a function inside, while the other one doesn't. Independent variable versus dependent variable, it depends on x. So u times v, product rule in my classes, but anyway, you learn it, it's fine. Derivative of x is 1, copy y to the 5 plus copy x. Derivative of y to the 5 is 5y to the 4 times y prime, or dy over dx if you want to write it down nicely. This might be a free response question or multiple choice. We sometimes give any. So that was the result of the first product. Minus y, derivative of y is y prime, equals derivative of x is 1 plus 15. Correct or not? Check. Correct or not? Stop. Step 1, differentiate everything. Not correct. So remember, you have to differentiate everything. Students make this mistake a lot because they feel excited they're done and forget to differentiate the constant. 15 gives you 0. Good job if you caught it. Now locate all the y primes everywhere. Locate the pieces that have y primes and move them to one side, while everything else should be moved to another side, like so. So x times 5y to the 4 y prime minus y prime equals, those are already on the left-hand side, so I keep it there, 1 minus y to the 5. Those are pieces that don't have y prime. The goal is to isolate y prime. And to isolate y prime, let's first isolate things with y prime. Now you factor out y prime to isolate it completely. Brackets x5 y to the 4 minus 1 equals 1 minus y to the 5. Last step, you can start looking at this one in the multiple choice, or if it's free response, then you write it down. Right-hand side divided by the brackets. Let me rearrange 5xy to the 4 minus 1. Let me check. Yeah, looks good. This is the answer for A, question A. Question B, then at what was it? 2, 1. How do you find at 2, 1? Remember that at 2, 1 means.
How did you find the -1 on the
-1
on number 3?
Oh, I factored this one. So when I factored y prime from both places, whatever stays was x5 times y to the 4, this one.
Oh,
and then minus 1. So that's not 0, remember. When you factor means dividing, y prime over y prime is 1. In this case, -1.
Okay.
Good question, Lisa, good job. X is the first variable, y is the second variable. And then so you just plug in y prime at 2 and 1 is 1 minus 1 to the 5. 5 times 2 times 1 to the 4 minus 1. And I made it on purpose simple, so it's 0. That is a slope for you to know. So for example, the slope at this particular moment is 0 at this particular point, 2, 1. That's it. Practice implicit differentiation. I have lots of videos on this, and you cannot do it just watching me doing it. You have to practice yourself. So this is good enough. Let's go to something you guys don't like, which is last 2 topics, related rates and elasticity, and then move back to the increasing, decreasing, maximum, minimum stuff. Related rates has lots of reading, and that's why it's kind of annoying. So I like choosing classical problems, like number 32, number 33 from your review, the one which is due tomorrow. So don't forget to do it. 32 and submit your work. Number 32 and 33. Those are very nice classical problems. We even did the balloon problem in class, which is 33. 32 is about the puddle. I actually like the idea of the leaked oil more because it's very realistic. There was an oil leak, if you remember, in Florida, like 5 years ago or something. Maybe it's already 10 years ago, I don't remember. And then when oil leaks on the surface of water, it's expanding circle. Not necessarily right circle, it's maybe ellipse. But this is a perfect idea of the related rates. Not only the radius is increasing, but also the area is increasing. To see or to find the speed of the increase of the oil leak on the surface of the ocean means to see how fast it will reach the shore. So I remember in Florida, they were evacuating people and animals from the shore and stuff like that. over here because they knew exactly when it will reach it with the current and wind and the given rate. And you can calculate the rate. So that's a very realistic idea. In this case, it's the radius of the circle puddle. So they say the radius of a circular puddle is growing. Why the puddle is growing? Okay. At a rate of 5 centimeters per second. Okay, growing means increasing, right? Derivative is positive. Remember that. If it says decaying, then derivative will be negative. Could probably, okay. So just to make sure you understand this, means derivative is positive. But let me finish writing. So question number 1, how fast? And now I can ask you 2 questions. No, I will do like this first. Without asking a question, I will give you the formula. Don't worry, I decided to give you the formula. In this case, we're talking about the area of the circle, which is A equals pi r squared. Like so. So they claim that there are 2 growing rates here. The area is growing and the radius is growing, just like in the simulation I just showed you. The radius is growing and the area is growing, and they are related rates. So when you differentiate them, even without the question being asked, you already can see what related rates we are talking about. It's implicit differentiation. So it looks like this. dA over dt, 2 pi r, I would move 2 pi dr dt, and those are 2 related rates. They're related via third variable t, like so. Now I can ask you 2 different questions. Either I can give you this rate and ask to find another one, or I can give you this rate and ask to find another one with the given radius. And your job is to understand it from words. That's the hard part. So how fast is the area growing? How fast is the area? Oh, so you see how fast is the area growing? When you read this, you're like, oh, I think I know what it means. The area is growing. The area is increasing. That is dA over dt, not known. And I can make a table already. dA over dt is question mark. At the instant when the radius is 10 centimeters. Okay, so the radius of a circular puddle is growing. That means this was dr over dt. dr over dt was given as 5 centimeters per second. This per in slash gives you the area. This is rate. But this phrase, radius, is 10, means that r is 10. This is enough to solve the problem. Plug everything in. Step 1, differentiate the formula we give you. dA over dt equals 2 pi r dr over dt. Done. Step 2, plug everything in. Don't plug right away. It will be the mistake. You have to plug after differentiation. dA over dt is a question mark. So we don't know that. dA over dt equals 2 pi times r is 10 times dr over dt is 5. And you got 100 pi. No, it's not 100. Why? Well, let's see. Did I miss something? Let me see. 2 pi r times r prime. R is 10. That one is 5. Looks good to me. 50 times 2, 100. Oh, seriously? They cut off the pi? The answer is 314. And I'm like, how can I get 314? That's so wrong. But fine. Don't touch pi. Pi is like a holy number. But yes, if you multiply by pi, which is 314, 59, and so on, then indeed it's going to be 314 centimeters squared per second. So wrong. I don't like when I'm doing that. This is the exact answer. Keep it exact. Anyway, it doesn't matter. You will see it as a multiple choice or free response. I will let you know how to input. Kind of, that's it. Can you do it on a test? And then practice separately. This will be recorded and posted, yes. And practice number 33 about the spherical balloon designed to pop at the instant of the radius, blah, blah, blah. We did it in class. Also very classical.
So is it best if we multiply by pi after we do the?
I will tell you
other
on the test. For the review,
Okay.
they multiply, I can see. I would not multiply. I think even typing pi should be fine. That will give you the exact answer. But they say round your answer to the nearest integer. I don't like it. But I don't take points when you guys do it. That will be also pretty mean.
Will you be giving us both equations on the test or just?
Yeah, I'll give you the equation that will be about the related rates. So if it's cubic, I will give you that, quadratic, triangle formula, but I don't plan to give triangle, to be honest,
So
problem.
will you give us the dA over dt equals pi?
No, this is the part of the related rates. This one you have to do yourself. This is not a formula, that's why. This is the formula. Like so. The second box is derived from this formula by differentiation. You see, derived actually means finding derivative. So that's the one you do by yourself using, guess what? Implicit differentiation. And that's why this topic always goes after implicit differentiation. Because we're kind of differentiating everything, left-hand side and right-hand side. So I just give you A equals pi r squared or cubic volume or cubic cube or Q, whatever else, triangle formula and so on. And then you figure out after this. So in number 33, for example, they're talking about volume of the sphere and we worked it in class. So I will give you this. Like so. And then you have to figure out what to do, which is exactly the same thing. You differentiate left-hand side, even without reading the problem. You already know how to do it. 3r squared dr over dt, like this. You're done. We're already done halfway through. Now you need to read all this paragraph of words and you use these shortcuts I gave you. Find which rate is given, which rate is not given, for example. Find the number to plug in r. Don't forget to have square if it's squared. Plug it in, solve it, you're done. Very good. These steps always work. Yeah. So that is number 33. Move on. That's kind of what I need you to know for the exam for the related rates. Related rates was the second worst problem from the vote, I can see. Next. Elasticity. Let's do some elasticity. I found nice files. I attached more files in the module. Let me see here. When you go to the module, scroll to the end as always. I do post lecture notes there in the good notes. You guys just don't check it, I guess, but you should, because people ask me, can you post the notes? And I already did it. At the end, it says lecture notes. I just don't want to make an announcement every time I do it because there will be lots of announcements. People already complain that they have lots of announcements. So this is, I have a YouTube video on this, elasticity of the demand. So you definitely should check it out. I followed it nicely, but this is PDF file from the video, like so. And then remember, being elastic means being really cool, to be honest. Elasticity means a good property. Being inelastic means you're stiff. You cannot be flexible. So this is how I memorize it. Greater than 1 means being cool. Greater than 1 means being elastic. Less than 1, you're weak. And by being weak, you cannot move. That's inelastic. Does that make sense? That's how I memorize it. Then I will tell you how I memorized the formula. But I also found this nice table I like. So I will use it right now. At the very end, check it out. This one is really good, I think. It's kind of also visual representation, the relationship between price and quantity, and then revenue and quantity. We found this formula by differentiating this graph, setting it equal to 0. And this is how the formula was derived. So again, greater than 1 means you're cool. That means you are elastic. Less than 1, you're weak. So you're stiff, not elastic. If you're elastic, that means you're so cool that if someone increases the price of the cookies, you like, screw the cookies, I'm not gonna buy them. That is why when you're elastic, if the price increases, the revenue decreases. We don't want expensive cookies anymore because we're smart or not addicted. If you are inelastic, means you're addicted to cookies and you have no choice. So if you are inelastic, when the price increases, you will be still buying them. That is a good example of what? Medicine or gas prices. You're still buying them because you have to go to work. You have no choice. Or internet, you still buy it because you have to do homework and so on and watch anime. And then if it's 1 unit, and inelastic means will not change revenue if you increase or decrease the price. So this is the good one, I think. And this is the one we did in class, but I kind of like this one more now. Copy. Okay, go. Elasticity. So there will be several problems on elasticity, understanding it and actually finding everything. This is because, let's see, elasticity. This is because it's a very closely related to your major. None of other majors learn elasticity of the demand. So I told you we were learning it when we were teaching business calculus classes. None of other classes teach us. Elasticity, E, why did I say L? E is less than 1, weak. By weak means stiff, not flexible. That means what? Inelastic, right? Inelastic. And that means, what does it mean to be inelastic? That means you cannot change your mind. So if price increases, revenue also increases. Because you have no choice. You are not flexible to switch to another cookies. You're too addicted to Oreos, for example. You are inelastic to change to another cookies. 1 unit elasticity, that means this before and after this moment. Now you can jump to being elastic or inelastic. Greater than 1 means you are, as the person who is buying things, you're cool, you're strong, and by strong means you're elastic and you can change your preferences for cookies. So if you increase prices of Oreos, you will say, no, I'm not gonna buy Oreos anymore, and the revenue goes down. That is the idea. So you will just switch to another company. So like Apple becomes way too expensive, people finally start switching to, or not, to Microsoft and so on. So that's the example. You are too big fan of Apple to switch, and that's why when they increase the price, their revenue still grows because you guys just big fan of it. But some people decided that no, they are done with Apple and they switch to another company, then they are elastic. So that's the idea. Now the formula, you will tell me how to memorize the formula. This is how I'm memorizing the formula. E is, I don't remember which one goes P over Q or Q over P. That was hard for me to memorize. So what I was thinking is, one thing is not changing is that Q, quantity, depends on price. So when you set the price, number of units being sold will change. Make sense? So if Oreos are 100 per piece, you will only send like 1 Oreo for like some rich tourist passing by. So that's the idea. But if Oreos are 50 cents per 100 Oreos, then you will sell hundreds and hundreds of Oreos. That is what I remember, definitely. Q depends on P. Then the derivative in the formula can only have one view or shape, dq over dp, because Q depends on P. So you differentiate Q with respect to P, not the other way around. And then the fraction in front of it flips P over Q. And I remember it should be negative. So this is how I memorize it. Maybe you have your own way of memorization, but visually remember that P and Q are flipped with in terms of derivative. So I first remember dq over dp, and then I put p minus p over q, and I remember it's negative. Anyway, the good news is I decided to give you this formula on the test. I decided, like, if you mess up the formula, you mess up the whole thing. And like, so I decided to give it to you. I will write it down over there in the test. But still, I think it's good if you remember. So let's do the example. Number 36. Lot of wordings, of course, as always, lots of writing. Number 36 says, oh, not too bad. The weekly sales of oranges, Honolulu oranges. Weekly sales of oranges. So do you know if you go to Whole Foods, oh no, to H Mart, they have those famous grapes, $25 per grape box, and I checked, it was half of the pound, so it's $50 per pound. That's how expensive they are. And I tried them because my friend bought it and he's rich, and they were pretty good. But why I'm mentioning this example, because this orange is also very expensive in this problem. Some kind of fancy oranges is given by, so you see Q depends on P. This is how it depends. The higher the price, the lower Q will be, because you see the negative sign. If P is 1,000,000, Q will be negative. So you will stop selling. Nobody wants oranges that have $1 million per piece. So that is exactly correct. Calculate the price elasticity. Find E, which is minus P over Q, dQ over dP, when price is $32 per orange. And that's why I'm mentioning the fancy grapes example, that apparently it exists. You know, why not? Now, after those grapes, I believe it's possible to have $30 per orange. So actually, I just bought some kind of orange, $6 per piece, because my rich friend told me they should be like fantastic. And I mean, they were okay. I don't think I will buy more. So that's exactly, that means I am elastic. I don't think I will buy more expensive oranges because they believe they're better than others. I will just switch to another oranges. So that's the idea exactly of elasticity. Solution. How do you start? Remember, I gave you steps. If you freak out, don't forget my steps. My steps are not required to be memorized, but they're good for the tests because then you know how to succeed. Right away, you start with finding the derivative. Step 1, find dq or dp, because it's in this formula. So just find this and you already feel like you know what you're doing. Just differentiate q with respect to p. Don't overthink this. 1040 gives you 0. Minus 20p gives you minus 20. So it's just minus 20. There is no implicit differentiation here, nothing. It's just derivative. Step 2, plug it in the formula. The formula is in front of you. E equals minus p over q, dq over dp. Now you have everything to plug in the formula. Minus p, just p. Q comes from the given formula, like so. 1040 minus 20p times the derivative you just found, minus 20. Look carefully and tell me if you understand this. This was the most important piece. When you figure out this, I don't think you will fail these problems. That's like 90% of work. Make sense? Step 3, plug the values they gave you, and we just give you one value. That is price. Price. And don't think this per. People now confusing with related rates. That's not related rate problem. Price is 30. Don't be confused. Price is 30. E equals minus 32. Why did I say 30? 32. 1040 minus 20 times 32 times minus 20, like so. Calculate whatever it is. I have it actually in my notes. I have exact answer. Approximately it is 1.55. Right? So what is the conclusion? We have 3 cases. bigger than 1, less than 1, equal to 1. That one is greater than 1. Remember, greater means strong. Strong means what? Elastic. So people who are buying those oranges are flexible, just like I bought this expensive orange and I'm flexible. I know I'm gonna buy it anymore. Elastic. That means they can change their mind. They're flexible. How to interpret this result? Let me see how they say it. They say, interpret your answer in interpretation. Okay, that's interpretation. So, will demand go up or down or stay the same? Remember my example, Julia bought that example, expensive orange for $6 per piece, which was still waste. I mean, that was good though, but not worth $6. The demand, now I'm not gonna buy it anymore because I'm elastic. So demand is going down. By elasticity gives you percentage. This is percentage by 1.55% per, that's the interpretation, 1% increase in price. Let me do dollars. 1% increase in dollars. So if they want to increase by 1%, I will buy every 1% increase in dollars for that oranges. People like me will buy less oranges by 1.55%. And now this expensive company, which think that the oranges are so precious, can decide how much it makes sense to increase the price and lose some people, but have high revenue. This is the idea. So when demand will go down when the price is increased, and demand means revenue, right? Revenue. How do you read it? Every time I stuck with this UE, every time I stuck with this word, because it sounds like new and it's not new. Revenue. So revenue is going down when dollars are going up, like so. Now, that's kind of a very good example already. Do you have questions about this? Because we will give you 2 questions on a test. Both might be multiple choice or both might be free response or one each. Interpretation, when we give you what elasticity is, I will give you like, okay, E is greater than 1. What does it mean? Or E is 1.55. What does it mean? Or E is 0.7. What does it mean? And then you choose the correct answer from the multiple choice questions. Okay, since this is greater than 1, it is elastic and blah, blah, blah. You know what to do. If it's less than 1, it's inelastic. So I don't have a choice but to keep buying those oranges, even though they are expensive for some reason. That is the idea. Checking the chat. Questions? Any questions? That is the elasticity of the demand. That's kind of all you need to know. See, this is good enough. If you can do this with steps, I definitely want to put it as a free response questions because it has steps. I can grade this moment, I can grade this moment, and I can grade this moment and interpretation. So this is a very good free response question. And then for multiple choice, I might just give some part of it, or maybe not. So that is to reveal how we create exams. So demand goes up. Let's check here, like so. For the inelastic, the revenue increases, exactly. For the inelastic, they can increase the price, and that will increase the total revenue, which is demand. For example, it still will increase their revenue. For example, electricity, gas. If you don't have a choice, you buy it, medicine. And that's what the example of inelastic items, like a basic one, basically, you know. For example, if there is a snowstorm and then they increase prices for shovels, people buy still more shovels because they need them right now. And that is a good example that at that moment, shovels become an inelastic product. When the snowstorm goes away, nobody cares about shovels anymore. And it becomes elastic now. Now you cannot just increase the price. People will just switch to another shovel. So that's just the idea here. So elastic means I can choose. So if they increase the price, I can just move to another place and it will decrease the revenue. But inelastic means I don't have a choice. If they increase the price, I will keep buying it. Now, optimization problems. Optimization problems. Your least favorite ones, as I can see from the vote. Go and vote, by the way. Kind of want to know. That's your chance to give a feedback in a discussion. Because I need to put several questions which will be doubled, and I need to know which one you hate, not so that I don't do that. For example, here it is. So for now, as you can see, it looks like this. Go and vote if you didn't. So optimization problem, we're going to do right now. Related rates, varied date, elasticity with date. So let's see. Taking a same exactly problem. Look at that. I'm going to cheat at the system here. I will take exactly the same problem. So just copy it. Copy it. But now I will, that is hardcore copying. But now I will forget about the question for the elasticity. I will just ask you what? Find the maximum. Let me check how to phrase it correctly. Calculate the price that gives the maximum revenue. Like so. That is optimization problem. Question. Find the maximum revenue. So I will have several steps. Find the maximum revenue. That is optimization problem. So I will erase the E part. I don't need that. And basically, I will just keep nothing actually. Here is the relationship between P and Q. Find the maximum revenue. Where is the revenue? That is not a tricky question because you already should be knowing this really well. Should wake up at night if needed and answer the question. How to find revenue? And you like revenue is P times Q. Done. Revenue is P times Q. So basically multiply the equation you see in front of you by Q. And this is how you can save time. You just multiply it and distribute right away. Check this out. Do you get it? No, I multiplied by Q and actually I multiply by P. Multiply by P by the other variable. So Q is given, then multiply by P. If P is given, multiply by Q. Done. That is my revenue. Because it's always the same idea. Revenue is numbers of units you sold multiply by how much money it costs per unit. It makes sense. If you sold 10 cups $2 each, your revenue is $20. So how to figure out that? Step one, build the revenue function. Step two, maximize it. Maximization and minimization problems always start the same. Find a derivative. Find R prime, which also called marginal derivative, marginal revenue. Marginal revenue by definition is derivative of the revenue. Differentiates with respect to P. It will give you 1040 minus 40P, like so. Did you understand the power rule? And then do what? Critical points. And critical points means z equal to 0. That is step three. Or step 2 in finding the maximum. So I will do like this. To maximize. Set it equal to 0 and solve for P. That's what you did in your quiz. P will be minus 40P equals minus 1040. Well, you better don't get negative price. That would be weird. Don't give me negative volumes and negative prices. P will be 1040 divided by 40, which is 26. I have it in my notes. $26. That is not the maximum revenue. That is the price that gives a maximum minimum. Price that gives a maximum revenue. That's a pretty cool revenue. That is a pretty cool idea that you can actually find mathematically. The best price for your object, in this case, oranges. They were selling at $32 per orange. And we just learned from the previous example that people will stop buying them. People are elastic for this problem. I will just stop buying them, they're too expensive. So let's decrease the price to have more people buying the oranges. So the lower price in the best price should be 26. Remember I told you, how do people on Black Friday decide what's the best price to decrease? Why it's not minus 40% or 60% or 72%? How do they know mathematically? So in this case, it says 26 will be the perfect number when the revenue will be maximized. So what is the maximum revenue? Plug into the original revenue equation. I'll just do EQN. Revenue is 1040p minus 20p squared. You plug 1040, 26 minus 20, 26 squared, and you get $135.20. So with this price, you can expect this revenue. That is the idea here. Questions? What do you think about that? While you're asking questions, let me check other optimization problems. But the idea is always the same. You find a derivative, set equal to 0, solve. And actually, you're supposed to check. In the quiz, I asked you to check that this point is indeed gives you maximum revenue using first derivative test. So check or actually justify. I will not ask it on the exam though. I think most of you will not do it or forget how to do it because it's kind of technical step. So yeah, I think it's nice not to ask this extra step. To justify, we use first derivative test, which is a sine line for the first derivative. Plug your critical point on the sine line. 26 is the critical point. And that takes us to the topic of what critical points are, increasing, decreasing interval. We're going to do it right now, and so on. So critical point by the definition is where derivative is 0, and it's always equal to 0 or D and E. Plug 26, that's the critical point. Take test points on the domain. So for example, revenue should not be negative, right? Some test points like 1 and maybe 100, whatever. Plug into your derivative. That's this notation helps you to remember this. Derivative. Let me find my derivative. It's over here. So when P is 0, the derivative is positive. When P is 100, 4,000 is too big and negative number gives you negative. Why this matters? Because the original function R, in this case, original revenue, not the derivative of the revenue, was increasing and then decreasing. And this is what we expect to have. Visually, it is indeed maximum, and we found the maximum. And that's the justification that indeed at 26, when price is 26, before 26, revenue is increasing. After 26, revenue is decreasing. So if you put $27 for that oranges, you will lose money. If you put $25, even though it's cheaper, you could do better with your revenue. So 26 is a perfect moment. And this is how you justify it using first derivative test. Let's practice that, but separately. If I don't ask you to just, I will not ask you to justify. On the quiz, I ask you so you can review. So you can review the whole idea. Let me see. Let's practice to find more local minimum and local maximum, global minimum, global maximum. Did you see on the quiz, by the way, that I gave you optimization problem from the review? I will tell you in a second. So absolute maximum, absolute minimum, let's do it in a second. Equation with tangent line. Yeah. You don't have lots of problems for that. So maximize the revenue, that's good. Find elasticity, that's good. I'm checking the exam. So it is on a test, definitely. Absolute maximum, that's the one you like. So I put it there. Implicit differentiation, it's there. Okay, fine. Let's do this one then. Elasticity again, credit rates, and lots of change. Let's do this one, this speed one. Acceleration. I think it's nice. Unless you get stuck with this. Fine, I like equation. I like problems with acceleration, but I don't know if you will remember that this is second derivative. So velocity is first derivative of the position function. Acceleration is the second derivative of the function. Let's practice one. So second derivative. Let's see. When you have position, right? Usually denote it as S of t, especially in America. They like doing that. I think in Europe we also do it S of t. Then if you differentiate it once, that gives you velocity. That is velocity. Then if you differentiate it twice, which means differentiate once the velocity, gives you acceleration. Acceleration. I remember teaching you this. So it was before my substitution, acceleration. Because I remember talking about funny names. Remember, jerk is a third derivative and stuff. So there's a whole joke about don't be a jerk. That means don't be a third derivative. So basically the short notation is from S to V to A, first derivative and second derivative. So position, velocity, acceleration. Thus, if I give you the position, that's number 29. Number 29. If I give you the position, S equals square root of t, it's always about t because they all depend on time, that makes sense. And ask you A, find velocity at t equals 1, for example, second, right? Then you do what? You find the first derivative. How to find derivative of the square root of t? That was exam 1. 1/2 t to the minus 1/2. Review that if you need. Plus 6t, that's the first derivative. Plug 1. 1 to the minus 1/2 plus 1/2 still 1. So don't care about that. Plus 6. That is 12 over 2 plus 1 over 2 is 13 over 2. That is velocity. So that is feet per second. B, find acceleration at t equals 1 second. Then you find one more derivative. So this was velocity, v. Find v prime, that is second derivative of s. That is my 1/2 times minus 1/2. T to the minus 1/2 minus 2 over 2 is minus 3/2 plus 6. And again, plug in 1. That is acceleration, by the way, at t. So A at 1 will be minus 1/4 because 1/2 times minus 1/2 is minus 1/4 times 1 plus 6. 24 minus 1 is 23. 23 over 4. I'm creating common denominator in my mind. You can use calculator if you want. And the units will be what? What's the difference with units? Yes, it used to be just per second, but we differentiate it one more time. So it's going to be second squared, like so. Because it's written like this, ds twice dt twice. This is the notation of the second derivative. You don't have to memorize this. I think we show it to you, but it's fine. Just prime is fine too. And that is acceleration. Questions? This is helpful. I'm not sure what are you talking about. It was a long time ago, but I'm glad it's helpful. Something is helpful. That's good. Questions? That is the upper derivative before we move on to increasing, decreasing, and concavity. That's actually almost done. We're almost done covering everything. Let me go to this. I'm going to go to our quiz. Who forgot to submit the quiz 1 hour before the deadline? It's crazy. I already gave extension and still received emails that you are late. Who does that? Who is procrastinating till last moment? So going to the top, I'm finding quizzes. Oh, I'm posting the quiz key, definitely. So quiz 6, I should not forget to do it after this review. So you have all the keys. Let's do it. 2 questions. Actually, all 3 questions from the quiz are very good. You better review them before the test. So let's do this one. Increasing, decreasing. Let's review everything at once. So let's call it like so. First derivative test. And that includes increasing, decreasing intervals. And that also includes local mean, max, remember? Let's review these problems. Y equals, my computer is overheating, 2 over x squared minus 36. If we ask you, find intervals of increasing, decreasing, and local mean max, what do? Correct. You start with finding the derivative, always. Y prime. This can be done using quotient rule if you want to, or chain rule. If you do chain rule, you write it down as 2x squared minus 36 to the minus 1. Let's practice chain rule because that's what I'm going to be asking you. But you could do this quotient rule and the answer is the same. In this way, though, chain rule says it's going to be minus 2 because minus 1 goes down. X squared minus 36, copy to the negative 2, minus 1 and minus 1 gives you minus 2 times 2x, derivative of the function inside. We already reviewed that. Why are you so hot? 56. Fine, I think it's just. Now, let me rewrite it nicely to see how it looks. It's going to be minus 4x over x squared minus 36 squared. This is my first derivative, y prime. I need to set it equal to 0 and d and e. D and e points are coming from the denominator being 0, and they are called singular points, remember? Singular points. Why just 0 points are called stationary points. Stationary points because when derivative is 0, something is staying at one place, constant. Constant speed, for example. The speed is not changing. That means derivative is 0. So singular points is where derivative is d and e. Those are d and e points, the bad points. Troublemakers. That comes from the denominator being 0. Let's check these. This we're doing right now, critical points, CPs. Minus 4x, let me put this negative sign like at the top over here. Minus 4x equals to 0. Come on, go on. Okay. x equals to 0 is my first critical point if it is in the domain, and it is in the domain. Denominator is x squared minus 36 squared equals to 0. Let's find that point. X squared minus 36 is 0. X squared is 36. X is 6 or minus 6. Remember, both should be included. Also could be critical points, but they are not because they're not in the domain. Not in. I will not put something complicated like this in a test, but on the quiz you had it, and if you watch my YouTube video, you saw how I'm doing it step by step. Not in the domain, because original function should not have 6 or minus 6 as inputs. That makes denominator 0. So these points came out from the equation, but they're not in a domain. They actually VAs, vertical asymptotes. There are two vertical walls. Now, this was step 2. So step 1, find a derivative. Step 2, find critical points. Step 3, first derivative test is making a sign line. I usually have notation. That's not all instructors do that. Sign line, you put your first derivative here, and then you put all these points you found, critical point and the bad points. And the notation for the bad points are vertical asymptotes like so. So apparently something's happening -6 and 6 because vertical asymptotes can change the behavior of the original function, concavity, increasing, decreasing, and that's what you had in your quiz. You saw it. Oh, people asking, what's the domain? A domain, let me review that. Here, that's a good place to write it down. Domain are possible inputs for this particular function. So for example, x should not be, so I'm crossing it off, x should not be 6 and minus 6. Oh, that's the wrong place to put it. I should put it here, higher. So since 6 and not 6 are not in the domain, they should not be counted as critical points. That's the definition of critical points. Inputs. The question on the exam will be easier than this, but if you can do this one, you are ready. That's why I put it on the quiz, because that question covers all possible cases. But I avoid using problems with vertical asymptotes for the exam. I checked before, and students usually miss them out. They don't notice. They do not notice this denominator because, you know, it's a stressful situation, timer is on the wall and stuff. So at home, I think you can notice it, but on the test, most people don't notice that they are vertical asymptotes. Continue with the first derivative test. Use test points like we did before. We have 4 intervals. Plug them in the derivative and check the sign. So very fast, and you can use your calculator. I have the key to speed it up. I can actually plot the function to see it. But let me just find the key. So, well, I probably should show you a couple. If I put -100 as a test point, why not? I like big points for some reason. Large points. This one large and negative. -100. -100 and -4 is positive. Divided by square is positive. So +100 will be negative, right? Because +100 times -4 gives a negative number. -1. If I like -1, -1 times -4 is positive. But then +1 is negative. Oh, I don't have a solution. Okay, good. So that was simple. So I plug into y prime. And that's why I'm calling it first derivative test, because we're plugging in the first derivative. And this is why this presentation is helpful. Why it's so important? Because now you can answer lots of questions. The original function, let me do it green, is doing what? When the derivative is positive, the original function is increasing. When the derivative is positive, the original function is increasing. When the derivative is negative, the original function is decreasing. When the derivative is negative, the original function is decreasing. Visually, this point is what? Maximum or minimum? It's the top of the mountain, so visually it is maximum. Either you memorize it, switching from plus to minus gives you maximum, or you visualize it going up and going down. Means you're at the top of the mountain, and that's maximum. Local maximum. Finally, we can answer all the questions. Answer. Increasing interval from -6. Oh, what? From -6. From minus infinity. From minus infinity to -6. From -6 to 0. See, I'm just doing all those intervals. Like so, interval where the function is increasing. The function is going, the original function is decreasing or going down. Yeah, come on. Can do it. Okay, good. Decreasing is from 0 to 6, from 6 to plus infinity, because derivative there is negative. Let me even write it down for you. Come on. Fine, let me shut it down for this thing. So switch, thank you. Decreasing has 2 intervals, see, like so. Immediately got faster. Now, what I was saying. I want to say, this note. The derivative is positive, the derivative is negative. That's how we know. That's how we know on those intervals. And that's how we know what's happening there. Finally, local minimum, local maximum, local minimum, local maximum. And I ask you on the quiz and on the exam to find both input and output. X, y, go. Do I see any minimum? No, because minimum will be going down and then going up. Well, maximum will be going up and then going down. So floor of the mountain, the bottom of the pit, yeah, that's minimum. The top of the mountain, that is local maximum. We don't have the bottom of the pit, so none. And then maximum, there is a maximum at 0. But how to find the output? Extra step is needed. Extra step. At the very end, extra step for these problems is always the same. Plug what you found into the original function. So I'm going back and finding the original function, which was what? Which was 2 over x squared minus 36. 2 over x squared minus 36. Plug into that original function. Y at 0 is 2 over minus 36, which is negative 1/18. Negative 1/18. That is how high the local maximum is. In this case, it's actually pretty low, but it's fine. Still local maximum. How about that? What do you think about that? That is a good problem, except vertical asymptotes, to give either multiple choice or free response, because it has steps. Just I can give some easier function, but can you do it? Increasing, decreasing, maximum, minimum. And then the other part of it is second derivative, which does what? Concavity. So find concave up and down intervals, also points of inflections. This is a topic I did not teach you, so you had substitution for that, but I had really good videos on this, so you can also watch these. POI, points of inflection, is the point that changes the concavity. POI changes concavity, This is about second derivative. Remember that. The moment you see these phrases like concavity, POI, that means we ask you to find second derivative. Find second derivative. That is derivative of the first derivative. So derivative of the first derivative. That function we had It was in the box. Remember, I have good habit putting things in the box. Here it is. Minus 4x over x squared minus 36 squared. Minus 4x over x squared minus 36 squared. X squared minus 36 squared. Prime. How to find second derivative of this? This is quotient rule. Let's review quotient rule really fast. Quotient rule is u over v, square denominator. Remember, I always say start with that. So it's going to be square square. Derivative of the top, minus 4. Copy the bottom, x squared minus 36 squared, minus. Copy the top, minus 4x. Derivative of the bottom is chain rule, because this function is this quadratic function with quadratic function inside. So 2 goes down. Copy. Change the exponent to 1 times the derivative of the function inside, which is 2x. This is a good example that reviews everything, quotient rule and chain rule. I went fast because you're supposed to be really good at this right now. I hope so. Chain rule isn't a test, so you need to be good at this. Now, simplified, set equal to 0 in D and E, right? And that's what I was looking for. My key, organized key. If oh, that was not as easy as I hoped. So I just really don't want to simplify it right now. Okay, I found a different. When was the last time we had quiz? Oh, just recently. Quiz 6. And I should put it anyways and post it anyways in Canvas. So found it. When you simplify it, it becomes like looking like so. It's global maximum, second derivative. Oh, nice. 12x squared plus 144 all over x squared minus 36 cubed. What do? We find critical points. So it was step 1. Find the derivative. Step 2. Critical points are coming from setting numerator and denominator to be 0. Stationary points and singular points. Well, 12x squared plus 144 does not give you any solutions because it's a positive number added to another positive number. No solutions. How will it make it 0? So critical points are only coming from a denominator. Minus 36 cubed equals to 0. And we have again plus or minus 6. They are not critical points, but we're going to put them on the sign line. Step 3 is exactly the same, but this time it's going to be, let's change the color, sign line for what? Second derivative. It's not second derivative test, but it's a second derivative sign line. I will just do y prime prime. Sign line for the second derivative. So draw a sign line, y prime prime. That's the indicator. Note that which derivative we will be plugging the test points in. Putting those annoying vertical asymptotes, minus 6 and 6. Again, I'm not going to give you asymptotes on the test. But now you can put your test points in the second derivative y prime prime. And this time, let's see what's going to happen. If I plug 0, it will be negative. And then minus 10 gives you positive, and 10 gives you positive, or minus 100 and 100. I'm plugging into second derivative to check the sign of the second derivative. Why? Because the original function is concave up when the second derivative is positive, concave up when the second derivative is positive, and concave down when the second derivative is negative. What's the easy way to remember? If you watched my YouTube video, you actually know my fun way of teaching this. because I don't know if the substitution did it my way or not, probably not. When the second derivative is positive, the original function is smiling. See? That means that you will have minimum at the tongue. See? Because it's at the bottom of the pit. So it's very nice visualization. That's how I teach it. When the second derivative is positive, the original function is smiling. When the second derivative is negative, the original function is grumpy. See? And then you have local maximum and the nose. Like so. That's a very fun way to remember it, and it works because there was a whole study that jokes and sense of humor helps people to remember formulas. Come on, don't freeze. Anyway, you got it. So now we can answer the questions. Where is the original function? Concave up, concave down, and if there are any points of inflections. Answer. So original function is concave up, where the second derivative is positive. Intervals are from -infinity to -6 and from 6 to +infinity. The original function is concave down from -6 and 6. And just like previously, I will give you the note. Second derivative is positive. And then second derivative is negative. To remember it, remember smiley face, grumpy face. So concave up means looking like a cup that can hold water. Concave down means like a mountain. And if there's a rain pouring, water will slide down. That's how I also like to teach. Points are in points of inflections should be changing concavity, but should be in the domain. Change the concavity, but being in the domain. So unfortunately, we cannot call -6 and 6 to be points of inflections. Not -6 and 6 because of that, because they're not in a domain. So none. In this scenario, it is none. Anyway, vertical asymptotes cannot be counted as points of inflections. They are just points of discontinuities or asymptotes. Yeah, that's important. What do you think about that? That was quite a lot. One problem on the quiz covered lots of stuff. 3 and -3. You mean for the test points? Well, there's the questions. Could I use the other way to do it? Like what? To do what? Because I kind of did quite a lot of stuff. For the second derivative, I don't know. What do you want to do? You have to explain. Instead of quotient rule, oh, you want to do product rule? You can do product rule if you want with chain rule, but it is either or. The answer will be correct. That's a very smart idea. There's a point in the chat that you can actually rewrite this as -4x times x squared minus 36 times -2. Now it's product rule instead of quotient rule. So this will be product rule. And we did quotient rule. I would do quotient rule, to be honest, but because there are more chances to mess up with chain rule, I guess. Both are fine. I guess whatever you like more. Good idea. What else? So that was a big problem. That's why this quiz is amazing. All 3 problems are really good, and I feel comfortable putting on a test, except asymptotes are definitely the overkill. And I'm not going to ask you to plot the graph, which is, by the way, looking like so. Like so. 2 vertical asymptotes, -6 and 6. Then local maximum, remember, was at -1 over -1 over 18, so it's a bit lower than 0, local maximum. And now we know that it's concave down from -6 to 6. So it's a mountain over here, or upside down cup from -6 to 6. Concave up before the asymptote. So there should be minus over here. And after the asymptote. Concave up means a cup that will hold water. This is the graph. And also increasing, if you remember, it was increasing before the asymptote, decreasing after the asymptote. So it also matches. So all the things help people to sketch the graph. But again, I'm not gonna ask you to sketch the graph in calculus for engineers with you. Finally, let's do optimization problems in global extreme values. Let's do global maximum, global minimum first, and then we'll do optimization problems. So we're almost done. Global optimization of global maximum, global minimum. It seems that people like it. And I saw on the quiz, even though some of you forgot how to do it, when you did it, you were like, that makes sense. That's actually not a bad problem at all. So let me find a good example. Do I have some? No. Like the one on the quiz was actually the best example. It's fast, simple, convenient. So I just put something like that usually on the test. Why bother creating something new if we already have good examples? Like so. Global, mean, max. That one I teach the way with a list. Remember, you're making a list. What kind of list? Critical points, critical points, critical points, end point A, and end point B. What do you do with this list? You plug all those points into your original function, choose the biggest one and the smallest one. So the only thing you need to know is to find critical points and then just plug it into the original function. Let's do it. Plug into. For example, the best examples are cubic functions, because, and actually if we check this one, maybe this one's good. Because when you differentiate them, they become quadratic functions. And then it's kind of, people usually good in finding roots. Just remember the quadratic formula. I actually reviewed it in lecture 0 for you, because I knew we will need it. Let's do this one. F of x is 2x cubed minus 6x plus 3. 20. Don't tell anyone. It's from your review. On and now, so the thing is, there's an infinite domain for this function, but we cut it. And now it's from -2 to 2. We call it restriction on the domain. So we're restricting the domain by cutting it from -2 to 2. Find global extreme values, global extrema. All of this means the same thing. Global extreme values, global min max, and so on. All of those questions have one thing in common. You start with finding the derivative, right? So do that. 6x squared minus 6. Boom, done. Step 2, find critical points. Where is your derivative? 0. And where it is d and e. Well, quadratic function can be d and e, so that is easy in this case. 6x squared minus 6 equals to 0. 6x squared equals 6. X squared equals to 1. X is plus or minus 1. Please don't forget, when you lose a negative solution, some panda is crying in the world. Don't make panda cry. It's very important. Both should be in the domain. Check. Check for extras. For extras. Extras are those that are not in a domain. X equals plus and minus are both are in the domain. That's important. Because you might have the example where the cubic function is like, or any function going up, down, up, right? You might have this point and this point, but the domain is only from here to here. So extras might be there. You need to kick them out. In class, I actually did example when one was extra. Okay. Step 3, make a list. It's magical list, and that's it. You're one step away from the solution. For the global extreme values, that should be a very good problem in the test. Hopefully, you just don't forget how to do it. List consists of all the critical points, which is -1 and 1, 1, -1, and end points, -2, and 2, A and B. And then you do what? You plug them into the original function. Plug into original one. Maybe write it down one more time if needed. So it's like in front of you, so you don't make a mistake. Maybe you will catch that you made a mistake when you was writing it down. Plug it and find, and then choose the winner. What is the biggest one and what is the smallest one? Let's see. When I plug 1, f at 1 is 2 minus 6 plus 3. 5 minus 6 is minus 1. When I plug minus 1, it will be minus 2 plus 6 plus 3. You can use a calculator, but don't forget to put parentheses for the cubic function. That will be 7. What is happening at minus 2? 2 times minus 8 plus 12 plus 3. That is minus 1. And what is happening at plus 2? It will be 2 times 8 plus minus 12 plus 3. That is at 2, 7. Choose the winner. The biggest output gives you the maximum, the global maximum. The smallest output gives you the minimum. Others are just extras. Well, it makes sense that sometimes functions have several global maximums or global minimum. Remember sine or cosine function. They have infinitely many global maximums and they all have the same level, 1. And they have infinitely many global maximums, which is global minimums, which are minus 1s. So we have 2 winners for the global maximum. Global maximum. Global maximum. And you can answer now global maximum is happening at x comma y. Don't forget the pair. Minus 1 and 7 and 2 and 7. And we have 2 winners for global minimum. Minus 1. Global minimum. Global minimum. And you can answer that. Global minimum will be also 2 pairs, 1 and minus 1, and minus 2 and minus 1. Can you do this problem on a test? What do you think of that? Can you do this problem on the test? Let me check the chat. That's good. Okay. So last thing we did not review from the list. Let me check my list. It's in the discussion. Go vote. We did chain rule, log and exponential. We did implicit differentiation. We did global maximum and minimum. We did local maximum minimum first derivative test. We did concavity and inflection point second derivative test. We did related rates and elasticity. What is left? Your favorite topic, optimization problems. We did example of finding maximum or maximizing the revenue, which is definitely something I plan to put because it's a business problem. So it makes sense to put it for business students on the test more than some kind of ladder slowing down and blah, blah, blah. But still, your review for the test in the web assignment has others. And my favorites are usually some kind of area, fencing problems, something that I did on the tests, just changing numbers. And these have several types of them, optimization problems. Put it in the rainbow. Optimization problems. Different types of them we usually teach. So maximizing area or volume, right? Or minimizing cost function or maximizing revenue. Revenue, that's a popular one. Minimizing or maximizing profit. What do you want to minimize? You minimize cost function. You minimize area, I guess, something like that. So kind of, I only figure out the cost. But anyways, so we had on the quiz a problem with rectangle and fence. Oh, that was a very classical one. We just already reviewed one problem for the maximizing the revenue. So you need to remember the revenue is Q times R, Q times P, quantity times price. And you have several problems like this, 26 and 27. what price will give the greatest profit? Number 26, number 27 asks this. What price gives you the largest annual revenue? Remember, revenue is price times Q. So I definitely plan to put something like this. For business students, it's basically the thing, probably on the final exam again. Anything more? The one we already reviewed only had second part of it. That problem was number 36. 36 and 37. 36 and 37. Second part asks for that as well. So make sure you understand that to maximize total revenue. And 38. And then what's not business problems are those box problems, triangle problems with the border fencing problems, which are either rectangular or circular and stuff like that. So number 24, I gave you on the quiz. I just copied from the review. So now you know how to do it because you did it for the quiz. Number 24 or quiz 6. There was a rectangular garden. I even gave you the sketch like so. And then for people who don't remember where the west, east, and south sides, I reminded you that it's west, east, north, and south, north, not north, and south. And then they say that the north side is already taken, so we don't need to put a border there. Sometimes we just say there's a river there. In this case, there was already a house there. So we don't need to pay for that side. But we need to build the area, the fence for the other sides, and they had different costs. So the cheapest one was east and west, $5 per, $5 each. But then the expensive one was south. For example, there's a gravel there, so it's hard to put fencing. So it was $10 per foot. So remember, it's per foot. How to build a cost function? Cost function will be food times price, right? Because it's dollars per foot. It makes sense. So cost function was west. Let's do widths and lengths, but I like doing X and Y because width W is already taken, but you could do small W. So that is widths, let's go to X, and lengths Y. Then you will have 5 times X plus 5 times X twice, plus 5 times Y, and you're supposed to have time 10 times Y one more time, but it's already taken by the building. This is S, not 5. This is your cost function. Cost function is 10x plus 10y, like so. And then actually this problem was changed to still minimize if I have a budget given, what are the dimensions of the garden? But sometimes we'll ask you to minimize the price if the area is given. So let's do that instead because it's more interesting. So if area is given, say 120 feet square. So I'm reversing the problem. In that problem, we ask you to find the area. Now I'm telling you that no, area is usually given, right? So I already have my yard size. Minimize the cost. So what is the price I will have to pay if I don't want to overpay? So for this problem, area is 120. Area has a formula which is width times length. In this case, it's X times Y. Your mathematical model will look like so. Like I will do like this. Model is A equals X times Y. Cost function is 10X plus 10Y. Area have to be fixed, 120. This is the mathematical model. Whatever has restriction calls constraints, basically restrictions. 120 is my limit of area for area. And the function that doesn't have any restriction. That's the one we need to optimize. And this one is objective function, right? That's what we call objective function. And we want to minimize that, minimize, in this case, minimize the cost function. So this is already like a nice thing. You build the model. Step one. So when you build the model, now calculus starts right after this. We don't know how to differentiate. We know how to minimize things. We need to find a derivative, right? This is the question, which can be written like so. Minimize cost function 10x plus 10y subject to. Have you heard this phrase before? You should write in the chat. Have you heard this phrase before? Subject to x times y equals 120. This is how you can rephrase this question. And you had it in your homework before. Minimize the cost function subject to. Minimize any kind of function subject to. Maximize any kind of function subject to. That means the function we want to differentiate versus the restrictions. So what steps we need to do that? Step one, solve for one of the variables, for example, x or y, from equation number one. And let me call them. Equation number one will be constraints and equation number two will be cost function. So this is equation number one. Okay, so I have x times y equals 120. Let me solve for y, for example, or x, doesn't really matter. Y is 120 over x. Sometimes there's a difference. One is easy to solve than another one. In this case, it's not. Plug, step two, plug into the other equation, equation number two. So I'm taking this y and plugging into c. Now my cost function looks nicer, 10x plus 10 times 120 over x. Now we can differentiate that. Step three, minimize. And we know how to do it. We already did it right now in this review. C prime is 10. You can simplify, right? It will be 10x plus 120, 0. So it's 1200 over x. Do you remember how to take the derivative of that? 10x gives you 10 minus 120, 0, 0, extra 0. I should not do that. X squared. Check it if you don't remember. You can rewrite it as x to the minus 1. That is exam 1, if you remember, power rule. Create common denominator. That will help you a lot. 10x squared minus 1200. And then I already said it so many times today in the review. Set it equal to 0 for D and E. So the top will show you zeros and the bottom will show you D and E points. Step 4. 10x squared minus 1200 equals to 0. 10x squared equals 1200. X squared equals 120, right? X equals plus or minus square root of 120. But you have to be in the domain. Well, let me actually finish the second part. X squared equals to 0. That means x is plus minus 0. But that's just it. So I have 3 points, plus minus square root of 20 and 0. But x should be in the domain. X is the side of the fence. The side of the fence should not be 0 or negative. So since x is the width in feet, then we have only one option. X should be plus square root of 120, which, by the way, is a simpler number, right? It is 4 times 30. 2 square root of 30. And 30 is what? 3 times 10, 5 times 6. No, I think that's the best. But it doesn't really matter. So this is the only option we have. You can check using first derivative test like I had before, and I had you to do it in the quiz, that indeed that is a solution. Remember, if you do check, how do you do it? Draw the first derivative test for the cost function for this critical point. And what do you expect to have since we're minimizing? Since we're minimizing, you expect to have minus and plus, right? Because you want the original function cost function to go down and then to go up to have minimum. That's true if you plug your test points into the first derivative, which is over here. You will have that. If you plug 1, you will have negative, and if you plug 100, you will have positive. So it's exactly the minimum we need. Answer. What kind of answers can you have? We found that x should be square root of 120, which is 2 square root of 30. We need to find y, and we need to find what is the cost function then. What is the minimum cost? How to find y? Go to that table, step 1. Here it is in the box. Y is 120 over x. 120 over x. So it's going to be 120 over a square root of 120. You can simplify it if you want. Doesn't really matter to me. Finally, what is the cost function? Go back to the table. That's why I like putting things in the box, and that's why I recommend you to do the same thing, because then it's easy to find them. You see, 10x plus 10y, or you can actually use the original. You can use this one also. That's also fine. But 10x plus 10y will give you the minimum cost. 10x plus 10y, which is 10 square root of 120 plus 10, 120 over square root of 120, whatever it is. That is your minimum cost function. Minimum cost function in dollars, while the other one are in feet. So those are the dimensions of the area of the fence. I'm tired, are you? So that is all. We actually covered everything. We covered everything I want you to cover, and just practice it a lot. Practice a lot, and practice interpretation. You have them in your review. Absolute maximum, increasing, decreasing, those things. Chain rule, basically, definitely practice lots of chain rule. Everything, I showed you everything you need to know. So now go rest, not to overflow yourself. I will post this PDF file and video. Go back, maybe tomorrow morning or whatever you can have energy, but do it. I also recommend waking up in the morning before the exam and doing, if you have time. It's like I was performing this Saturday, dancing performance. I did. So what did I do? I woke up early, 7 in the morning, and I practiced and danced twice. That's what I did before each exam as a student. And it works for me, definitely. It works. If in the morning you do it, your brain remembers it, because in 2-3 hours you will have this on the test. So it's really cool to do it on that day one more time. Questions, critics, comments, appreciation.
Thank you.
You're welcome. Good job for staying so late.
Mhm.